Okay, on to the next one. Equations and graphs of trigonometric functions. Why are we doing this in this section? Well, we just finished first two parts on solving trigonometric equations. Well, we're going to look at equations and graphs of trigonometric functions to explore how to solve these trig functions graphically. Okay, first let's do a quick startup. Determine algebraically the solutions for the equation 4 sine squared of x minus 3 equals 0 for the interval 0 to 2 pi. So let's take a look at this. What do we got? First, let's start with 4 sine squared of x equals 3. I'm going to add 3 to both sides. Let's divide both sides by 4. Sine squared of x equals 3/4, and I'm going to take the square root of both sides to solve for x. So that gives me a plus minus square root of 3/4. And so sine of x equals, well, I have a bunch of possible solutions. So sine of x equals plus or minus square root of 3/2. So to find the reference angle, I'm going to take the inverse sine of the absolute value of square root of 3/2. And so my reference angle becomes pi/3. Okay, what do I do with this pi/3? So review again, folks, when we're solving. Okay, I have to look at it in the quadrant. Here, sine of x is greater than 0 in quadrants 1 and 2. Also, sine of x is less than 0. So I have two cases where it's positive and negative in quadrants 3 and 4. So I actually have 4 different solutions here. In quadrant 1, my angle in standard position, x, is equal to the reference angle, and that is equal to pi/3. That's the first solution. Quadrant 2, my angle in standard position equals pi minus my reference angle, and that equals pi minus pi/3, and that is 2 pi/3. Quadrant 3, angle in standard position equals pi plus my reference angle, and that equals pi plus pi/3, and that is 4 pi/3. And in quadrant 4, my angle in standard position equals 2 pi minus pi/3. Oops, 2 pi minus, just first in general form, xr, the reference angle, and that equals 2 pi minus pi/3, and that is 5 pi/3. Okay, so I actually have 4 different solutions here based on a reference angle of pi/3. So verify your answer using technology. So I'm going to graph this using my x window is 0, 2 pi, and pi/6. And my y window is -4, +4, and 0.5. And let's take a look at what this looks like here. Yeah, let's try to squeeze it in here. Basically, what does this look like? Going to have this function okay, and so right here, 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 and here, those are my 4 solutions. Let me just pencil this in. That's pi/3 This is 2 pi over 3. This is 4 pi over 3. And this is 5 pi over 3. So there's an algebraic and graphic graphing solving of this problem. Let's explore now solutions to multiple angle equations graphically. So use a graphical approach to determine the solution to the equation. Cosine of x equals square root of 3 over 2. Okay, so let me pencil in my axes here. So this would be the y-axis here. And what does it look like? So, let me make that a little bit nicer looking. That looks much better. Okay, and then, so the red is y1 equals cosine of x. And then in blue, y2 equals square root of 3 over 2. So we use our graphing calculator. We graph the intersection points. I'll do that in green here. It's within this domain of 360. So 360 would be right at that maximum. This is 360 degrees. Okay, so the solution I get here, first one is 30 degrees. That's as we expected. And then where's cosine function? Where's cosine of x positive? Well, that's quadrant 1 solution. And then the other one would be quadrant 2. So this is 330 degrees. And this is in quadrant 2. Okay. So the solutions I have here are x equals 30 degrees and 330 degrees and 330 degrees. Okay, letter B. Use a graphical approach to determine the solution to the equation cosine of 2x equals square root of 3 over 2, where x is between 0 and 360. Okay, what's the only difference here? Well, I'll highlight it. There's a 2x and an x. Okay, before I graph this, let's think about this using transformations. Think about it from a transformations perspective. The difference here is b equals 2, which means that 1 over absolute value of b, 1 over 2. So this is 1/2 factor. So all x values multiply by 1/2. Let's keep that in mind and see what our solutions end up being. Okay? All right, so I'm going to draw my x and y axes here. And then I have my sine function. This time it's y equals cosine of 2x. So that is a horizontal stretch by a factor of 1/2 about the y-axis. So it's going to compress it like a spring, right? So okay, something like that. Let me go up there. And then this is y equals cosine of 2x. So when you're graphing it, y equals cosine of 2x. And then let's do a blue line here, still same. So the blue, that's y equals square root of 3 over 2. Well, where does it intersect? Now within this domain, I'll have 4 solutions. I have 15 degrees. I have 165 degrees. Third solution, 195 degrees. And then this one right here is 345 degrees. Okay, now we're going to compare, but remember this discussion that we had about transformations. That's one way to think about it, and graphically solving this. Letter C, compare the number of solutions. Compare the solutions to the two equations in terms of the number of solutions. So within domain 0 to 360, it's 2 versus 4 solutions. The values of x. The first two solutions of cosine of 2x equals square root of 3 over 2 are exactly 1/2 the value of the solutions for y equals, for cosine of x equals square root of 3 over 2. This makes sense, not only from a graphical standpoint, we just graphed it and showed it, right? This makes sense. Okay, so 30 times 1/2 equals 15 degrees. 330 degrees times 1/2 equals 165 degrees. Okay, so 30 degrees, 15 degrees. 330 degrees, 165 degrees. Okay, so we can see the transformation in action there. This makes sense. Okay, we had a horizontal stretch by a factor of 1/2. The general solution to cosine, so we're on letter D here, folks. Consider, complete the following. The general solution to cosine of x equals square root of 3 over 2 is, let's see, x equals 30 degrees plus 360 degrees times n, and 330 degrees plus 360 degrees n, where n is an element of all integers. The general solution to cosine of x equals square root of 3 over 2 consists of two sets of answers which differ by 360 degrees, because the graph of y equals cosine of x has a period of 360 degrees. Letter 3. Number 3. The general solution to cosine of 2x equals square root of 3 over 2 consists of two sets of answers which differ by 180 degrees. Okay, so the two sets that we're speaking of is 15 degrees and 195 degrees. That's the 180 difference. And then 165 degrees and 345 degrees. That's the two sets that differ by 180. The general solution to cosine of 2x equals square root of 3 over 2 consists of two sets of answers which differ by 180 degrees because the graph of y equals cosine of 2x has a period of, you guessed it, 180 degrees. The general solution to general solution to cosine of 2x equals square root of 3 over 2 is x equals 15 degrees plus 180 degrees n, 165 degrees plus 180 degrees n. N is an element of all integers. Okay, one other way, this will kind of foretell what we do later when we use the double angle identity to solve trigonometric equations, but let me show you this little tidbit here. So if I go cosine of 2x equals square root of 3 over 2. Well, let's solve this for 2x. So stick with me here. 2x equals the inverse cosine of the absolute value of square root of 3 over 2. 2x equals, well, what's the inverse cosine of square root of 3 over 2? Well, that is, go back up here. That's 30 degrees, right? This part, 30 degrees. And let's call this the reference angle, right? So that is 30 degrees. The reference angle is, I'm going to divide both sides by 2. So that's 30 degrees divided by 2. Reference angle equals 15 degrees. Wasn't that what we had right here? 15 degrees. So if I think about another way to look at this, right? If I have 2x equals 30 degrees plus 360 degrees n, and the other solution was 330 degrees plus 360 divided by n, or sorry, times n. We said the b value equals 2, which gives me a horizontal stretch factor of 1/2, which means all the x values, so all the values in degrees, are multiplied by 1/2. So when I divide by 2, think about that as multiplying by a factor of 1/2. So when I do that, what do I get? 15 plus 180 degrees n, and this is what's half of 330? 165 degrees plus 180 degrees n. Okay, and that's exactly what we have when we consider how to solve a double angle identity, a double angle trig equation algebraically. All right, so this is just foretelling what we're going to do later on in this unit. Next page. So another example, this time I'll give you a graph. The graph of y equals 6 cosine of 4 alpha is shown below. Use the graph to solve the equation 6 cosine of 4 alpha equals 6 for this domain. Okay, so what I'll do is y equals 6. So I'm going to look at it like this. So if I graph this on my graphing calculator, my y1 value would be 6 cosine of 4 alpha, and my y2 would be 6. So if I graph 6 up here, here's y2 equals 6. So I'm going to have what? This is all the way up to 2 pi. Oops, that's up to, yeah, they want the domain up to pi, so this is roughly pi. So I'm going to have 3 solutions. Okay, use the graph to solve. So when I do that, what are my 3 solutions? X equals 0, x equals pi over 2, and x equals pi. So the solutions are x equals 0, pi over 2, and pi. Let's state a general solution to 6 cosine of 4 alpha equals 6, where all real numbers is the domain. So to me, the variance here, from here to here, That's pi over 2, folks. From here to here, pi over 2. And on and on and on. If we keep stretching this graph in the right direction and then in the left direction, positive and negative direction. So my general solution is pi over 2. It varies by pi over 2 units. Okay, so and n is an element of all integers, right? So when n equals 0, x equals 0, and that's what we get, right? Right there. N equals 1, x equals pi over 2. And that's what we have here. And so on. So n equals 2, x equals pi, and that's that solution. And you keep going on and on in the positive or negative directions, you got your general solution. Letter C, graph y equals 6 cosine of 4 alpha on your calculator, and use this graph to solve the equation 6 cosine of 4 alpha equals 3, where this is our domain to the nearest degree. So we're going to do a little rounding. So when I graph y equals 3, so 1, 2, 3, right here. So in the domain 0 to pi, so I have how many solutions? 1, 2, 3, 4 solutions. And that's pi over 12, 5 pi over 12, 7 pi over 12, and 11 pi over 12. And that I got with my intercept function, so to the nearest degree. So x equals 15 degrees, 75 degrees, 105 degrees, and 165 degrees. So I know I stated it initially, the solution's in radians, so I'll just write the radian values underneath. Okay. All right, you try. So pause it here, give it a try, and then let's take a look. The general solution to sine of x equals square root of 2 over 2 is x equals pi over 4 plus 2 pi n, x equals 3 pi over 4 plus 2 pi n. And that makes sense because those are the two solutions. This one is in quadrant 1. This one is in quadrant 2, where sine ratio is positive. Okay, so let's determine the solution to sine of 3x equals square root of 2 divided by 2. If I graph sine of 3x, so do that on your graphing calculator. So sine of 3x, so y1 equals sine of 3x, and y2 equals square root of 2 over 2. And let's find the intersection point. So square root of 2 divided by 2. Then we graph that. Okay. I'm in radian mode, folks. So when I look at this, there's my two axes, x and y axis. And let me go 2 pi. I'm going to set my window to 2 pi. Okay, so let's see how this varies. So my graph looks like this. Oh man, let me see if I can draw a proper graph. Sorry about that, folks. Okay, so that is y1 equals sine of 3x, and y2 square root of 2 over 2. Well, where are all the points that it intersects? Let's take a look at the first 4 points here. If I do the intersect function here for that first point, okay, I get an intersection x value of 0.2617994. Yeah, that's pi over 12. Okay, so this one is pi over 12. Okay, what's this next one here? So if I do that intersection point, go back to my graph, intersect, I get 0.7853982. Well, that suspiciously looks like 3 pi divided by 12. Yep, so this is 3 pi divided by 12. And then if I look, these look like they vary periodically, but by how much, right? So we can think of it this way. I'm going to just start with these, and I'm going to build my general solution this way. Okay, so I'm going to think of it like this, folks. If sine of x equals square root of 2 over 2, let me make a little bit more room here. I'm just going to scoot this over a little bit right here. This is y2 equals square root of 2 over 2. Okay, if I have sine of x equals square root of 2 over 2, well, we've done this so many times. The solution is x equals pi over 4 plus 2 pi n, and x equals 3 pi over 4 plus 2 pi n. Okay, when I have sine of 3x, let's look at it from a transformation standpoint. My b value is 3. So for sine of 3x, my b value equals 3. My period, right? My period will change. My period goes from 2 pi, so 2 pi over absolute value of 3. So the new period should be 2 pi over 3. Okay, let's remember that. So here we go. Sine of 3x equals square root of 2 divided by 2. And that equals, we said our first value, so I'm just going to get rid of this to make a bit more room. We said our first solution was pi over 12, and our second solution is 3 pi over 12. Well, what's the periodicity? Well, if the b value is 3, let's think of it this way, folks. Sine of 3x equals, if I do this, sine of 3x equals square root of 2 over 2. Well, 3x equals pi over 4 plus 2 pi n. Well, if I divide both sides by 3, let's see. Well, I didn't give myself a lot of room. Let's do this. From here, if I say 3x equals square root of 2 over 2, 3x equals pi over 4 plus 2 pi n. I divide both sides by 3. I get pi over 3 times 4 plus 2 pi over 3n. Well, this is just pi over 12. And that's how I get my periodicity there. And this has to be the same as well, 2 pi over 3n. Okay, so let's test that out by just looking at our graphs. Remember this part. Okay, let's look at this one right here on our graphing calculator. So when we graph it, when we do the intersect, I get 2.3561945. So this one is x equals 2.3561945. What if I take pi over 12 plus 2 pi over 3 and the n value is 1? What do I get? That is pi divided by 2 plus 2 pi divided by 3 pi over 12. Sorry about that, folks. Let me do that again. Pi divided by 12 plus 2 pi divided by 3 times 1. I get, look at that, 2.3561944, and then if I round, it's the same. Okay, so that works. What if I do, and then you can try the same for this one where you add 2 pi over 3 to that. So that's how I get this part here if you just do n equals 1. Okay, all right. That was an interesting one. So I showed you algebraically and graphically how the solutions work. Let's go to number 2, finish this off. The smallest positive solution to the equation sine of 4x equals 0.48, correct to the nearest hundredth of a radian is... Okay, so let's graph this. So we're looking at it graphically. I'm going to graph y equals sine of 4x and y2 equals 0.48. Okay, so I'm just going to set a x max window of pi. Okay, so I get a graph like this. Oh man, let me draw that better. Okay, something like that. And then I have that. Okay, so this is y2 equals 0.48. And then this graph is, of course, our y1 equals sine of 4x. Okay, and then let's look at this intersection point right here. What is this intersection point? Okay, use your intersect function on your calculator. I get x equals 0.1251637, rounded to the nearest hundredth. We want the smallest positive solution, so that's the smallest positive, rounded to the nearest hundredth of a radian. That's 0.13 is our intersection point.